Task number 9, SSH Authentication, is part of the Encryption Crypto 101 module, which is part of the complete beginner path on TryHackMe. Let's download the task files. Encryption and SSH Authentication. ID RSA. We see in this file so far. By default, SSH is authenticated using usernames and passwords in the same way that you would log in to a physical machine. At some point, you're almost certain to hit a machine that has SSH configured with key authentication instead. This uses public and private keys to prove that the client is a valid and authorized user on the server. By default, SSH keys are RSA keys. You can choose which algorithm to generate and/or add a passphrase to encrypt the SSH keys. Here we see the SSH keygen, which is a program used to generate pairs of keys most of the time. SSH private keys. You should treat your private SSH keys like passwords. Don't share them. They're called private keys for a reason. If someone has your private key, they can use it to log in to servers that will accept it unless the key is encrypted. It's very important to mention that the passphrase to decrypt the key isn't used to identify you to the server at all. All it does is decrypting the SSH key. So the passphrase is never transmitted and never leaves your system. Using tools like John the Ripper, you can attack an encrypted SSH key to attempt to find the passphrase, which highlights the importance of using a secure passphrase and keeping your private key private. When generating an SSH key to log into a remote machine, you should generate the keys on your machine and then copy the public key over, as this means the private key never exists on the target machine. For temporary keys generated for access to CTF boxes, this doesn't matter as much, right? So basically when we use SSH, we should generate the key on our machine and copy the public key over, as this means the private key never exists on the target machine. So when we generate an SSH key to log in an SSH service, we should generate on our machine the public key, right? How do I use these keys? The home.ssh folder is the default place to store these keys for OpenSSH. The authorized keys, note the US English spelling, file in this directory holds public keys that are allowed to access the server if key authentication is enabled. So we have key authentication, as we read so far, and user password authentication. By default on many distributions, key authentication is enabled as it is more secure than using a password to authenticate. Normally for the root user, only key authentication is enabled. In order to use a private SSH key, the permissions must be set up correctly, otherwise your SSH key will ignore the file with a warning. Only the owner should be able to read or write to the private key. 600, right? Or stricter. And here you can see SSH interface key name goes here, and then user host. This is how you connect with SSH via the IDRSA file. Okay, it's how you specify a key for a standard Linux of OpenSSH client, right? And here 600 refers to the permission. Using SSH key to get a better shell. SSH keys are an excellent way to upgrade a reverse shell, assuming the user has login enabled. www data normally does not, but regular users and root will. Leaving an SSH key in authorized keys on a box can be a useful backdoor, and you don't need to deal with any of the issues of unestablished reverse shells like Ctrl-C or lack of tab completion. Answer the questions below. I recommend giving this a go yourself. Deploy a virtual machine like Linux Fundamentals 2, which we did, and try to add an SSH key and log in with the private key. We will do this in the following questions. Download the SSH private key attached to this room. Basically, we have it over here. And this is what you can generate with this tool, with SSH keygen. Right, this is complete. What algorithm does the key use? RSA, right? We know by now. The RSA. Crack the password with John the Ripper and rock you. What's the passphrase for the key? Okay. Okay, cool. So, it's delicious. If we would try now to log in via SSH, it will be like this. Exactly. We see it over here. We provide the key, the private one. And then here for the password for the user, we'll say admin or root, sorry. Because root and other users could log in with this private key. And here we'll introduce the IP of our machine. Right, and after we hit enter, we can log in with SSH. This is basically what we basically have to try to do here. Awesome.